The tangent line problem is the problem of finding a tangent line to a graph at a given point. So for example, this is the graph of s of t equals minus 16t squared plus 96t. So this is a parabola, concave down and all that. And let's say I want to find the tangent line at point A, right, which is 1, 80 at that graph, right? So tangent comes from the Latin tangens, which means to touch. So the tangent line is the line that just touches the graph at that point. So it just touches it at point A right there. Okay? So it exists. It is there. We just don't know its equation. We have a point for it already, and we want to know the slope of that line. Because if we do, since we already know a point, then we can find the equation, let's say the point slope equation of that red line right there. If you graph the equation of a secant line, let's say, with a time interval between 1 and 3, right? So this being your delta t, and the time interval or a y change, right? Change in s. This is going to be your delta s, this is going to be your delta t, between s of 3 and s of 1. So that's going to be the slope of this black line from A to B. That's what we call the secant line. It's a line that intentionally touches 2 points, not just touches the graph. So the idea of finding the tangent line is to make this delta t smaller and smaller so that this black line gets closer and closer to the red line. And using words and the idea of limits, one would say that the limit of the slope of the secant line as delta t approaches 0 equals the slope of the tangent line. Here we have the exact situation we were talking about before. This is a GeoGebra construction. You can see, and I'll walk you through the left sidebar one at a time first. This first purple circle that you see filled in on the left side is s of t. It's minus 16t squared plus 96t, the equation of the height of the football. 1 comma s of 1 is point A that you see also in the blue graph. Below that you have t. Right now t equals 3, but t can change from anything between 1 and 3, right? And b is going to be t s of t. So it's a point that changes as I move t, as I change the value of t, right? B changes. And that's the beauty of this. The black line below B on the left there, line F, is a line that goes through points A and point B. A is a still point, and B is a point that changes with t. So the line, the black line, changes as I make t closer to 1. Look at what happens. What is A below F? A is s of t minus s of 1 over t minus 1. So A is the slope of the black line. Change in s over change in t. Take a second to recognize that. And right now, when t equals 3, A equals 32. It's just doing the math for us, but we can do it ourselves if you wanted to. And then, as I make t change, you can see A changes as well. And the closer t gets to 1, A is going to approach some value. Note that when t exactly equals 1, then A is undefined, because that would mean A equals to s of 1 minus s of 1, which is 0, divided by 1 minus 1, which is 0. You cannot divide by 0. So A is undefined. You can't just plug in t equals 1. But if you make t close enough, you can get some sort of approximation. I'll guess a is about 64, right? The closer t gets to 1, the closer a gets to 64. So that's to say, the limit of a as t approaches 1 equals 64. But right now that's just a guess. We haven't formalized this, but that's a guess. And I can animate this to keep that going back and forth. And the red line for us is going to be the tangent line, right? I would guess then, based on these observations, that the slope of the tangent line, the slope of the red line, equals 64. And that's the whole point of this.